Before there was autofocus, there was focus. The camera is a light-tight box that is used to expose a photosensitive surface, film or digital sensor to light. In order to focus the light onto the surface, cameras and your own eyes use a lens to direct the light. A lens is an optical device that consists of a curved material that allows light to pass through it. Depending on the design, a camera lens, either built into the camera or attached and interchangeable, consists of one or more elements that both diverge and converge light to focus it onto the photosensitive surface and reassemble the light. The light reflecting from the scene that has passed through the optics results in an image. As anyone who has used a magnifying glass to try to burn holes in paper or leaves can attest to, there is a direct correlation between the convergence of light and distance from the object onto which you are trying to project that light. When you try to focus the light of the sun into a tiny spot to start a flame with a lens, you are focusing the light from a single light source. The camera, as well as your eye, is focusing the light from not only potentially many light sources, but an infinite number of light rays that are reflecting from objects in the scene. Moving the lens closer or further from the sensor or film is how the camera and lens work to channel the light to recreate the image clearly. If you could not adjust the focus of the camera and lens, you would have to move physically closer or further from the objects, just like you did with your magnifying glass and the sun. Luckily for us, most cameras do the moving for us. Reflected light from that eyelash is entering the camera's lens at different angles because it is reflecting at a nearly infinite number of angles. The lens's job is to collect those light rays and make them converge onto the film or sensor at a single point so that we can reproduce the tip of that eyelash on our photograph exactly the same as it appears to our eye. If that light converges at a point before the sensor, the eyelash tip will appear blurry, as the light will converge to a point and then continue on its merry way, diverging from the point. Similarly, if that light tries to converge at a point beyond the film or sensor, the light impacting the plane will not yet be brought to a single point, and we have the same effect. What is this effect? An out-of-focus image is created. The tip of that eyelash is reproduced as a fuzzy collection of reflected light that will resemble a blurry eyelash tip. Now, imagine that an infinite number of times and from every point of light or reflection in a scene, blurry. You will want to control how out of focus your images are. To allow your image to be sharp or to allow you to intentionally not focus, the camera and lens work together to change the distance of the lens from the sensor or film in order to control where the captured light converges. When the light converges precisely at the plane of the film or sensor, the image is in focus. So, on a camera with a lens that has a rotating mechanical focus ring, By turning this ring, you will physically move the focusing lens or lens focusing group to manually change the distance between the lens and sensor and allow the control of where in the camera that light converges.